recording. Oh, I see. Okay. Thank you very much, Luis. So in this next half an hour, I hope I will provide you a tutorial about the network slice controller. So, my name is Javier Velázquez. I work for Telefónica. And just as a brief introduction, this component I'm going to present was introduced to TerraFlow the last release, not this one, and the idea is that this component is an independent component that can work isolated, but it is also integrated with TerraFlow. Well, it's in the road to be fully integrated with TerraFlow. In fact, there are some challenges that help in this full integration with TerraFlow controller. So I hope that this is not boring for you and you find it interesting. So the idea is presenting you an introduction of the component, a little bit of theory to put you in context of this component, and then we will go with the demo and tutorial. Okay, so just a presentation of myself and the group of Telefónica that is working here. As I mentioned, Telefónica became part of TerraFlow SDN with this component in the last release and became a module development group that is basically a branch of the TerraFlow SDN community where we are contributing with the network slice controller. So who are we? I am Javier Velázquez. I'm the main developer of this component, and the leader of this group is Luis Miguel Contreras. So you have our emails there in case you are more interested on the component. You can contact us. So a brief introduction and some theories. So as I don't know the background of yours, I will just start with the topic of network slicing. I don't know if network slicing is familiar for you or not. I don't know. Maybe someone can say something of what they think that is network slicing.
So my understanding is, I understand a little bit the concept. So my understanding is network slicing like something network surface specification specified for some specific requirement or for some customers. So like what kind of wavelengths, what kind of surface, because different customers have different requirements on different bandwidths, different data rate, then we have to slice the specific requirement for each customer. So this is my basic understanding. It's correct?
Yeah.
Maybe not.
Yeah, it's a good approach. Yeah, it's a good definition of network slicing. As you mentioned, no, it is something specific to the customer. I always like to put some images that illustrate some one specific use case that network slicing covers. That it solves situations where in this case the mobile network becomes saturated with because many people is gathered in some place, and the connectivity get really slow, and everybody gets a poor user experience. So network slicing solves somehow this problem and provides a customized connectivity service to the customers with specific capabilities and characteristics. So part of the network is, let's say, reserved for these users. so they can increase and improve their user experience while using the network, the internet, and so. So with this concept, we go to the standards. We go to 3PP. 3PP, as you may know, was the one that defined the first release where 5G was defined. And in 5G, they defined this term of network slicing, where in this document that I don't recommend you to read it, it's very boring, but they basically define the network resource management model where they defined network slices. So basically there what they defined is that a network slice involves a set of different network functions and resources. So basically, it involves, in the case of the 5G network, some radio access network functions as well as core network functions. But there is a problem here because somehow the transport is here not addressed. It only addressed RAN and core components. So in this document, they don't address specifically how these functions are connected. And that's why the transport somehow is here. There's a gap here because there's no definition for the transport network. So to cover this gap, a new standard organization appears, that is IETF. So they define their own definition of network slicing, which is basically network slicing focused on the transport. And for that, they defined it in this another boring document, the RFC 9543, where they define a framework for network slices in network build from IETF technologies, which basically covers how these core and RAN functions that are reserved in the network slice defined by 3PP are joined together in the transport. But this is not only restricted to 5G and mobile networks. The IETF opens this space for other domains, such as private networks, data centers, whatever. I mean, IETF network slicing can be used in such many domains and use cases. So, they defined it, the IETF network slice as a logical partition of a network that enables connectivity between a set of SDPs, that the SDPs is the acronym of source demarcation point, which are basically the endpoints that in the case of 3PP would be these RAN and core functions, with specific SLOs and SLAs, which are basically the requirements of the slice, such as latency, bandwidth, availability, whatever, over a common underlay network.
Sorry. Sorry.
Yes.
What does SLO and SLE exactly represent?
Yeah, SLO and SLE are the acronyms of service level objectives and service level expectations. Service level objectives would be these requirements I talked about latency, bandwidth, are like some specific numbers for the slice you want them to meet. For example, I want a slice with no more than 10 milliseconds of latency, for example. And service level expectation is a more broader term that does not specify a specific number. And for example, an example of a service level expectation would be security. I mean, I want a slice that comes with security. I don't define a number specific, I just want it to be secure. It's like really unspecific and and yeah, they cover more of broader terms like that.
So the objective should be the target. And expectation also some kind of target, yeah?
Yeah,
looks to
they're
me
both.
similar.
Yeah, they're both targets, but SLO defines it's something measurable. Let's say, like you
Okay.
can measure latency, you can measure the occupation of a link, but in the SLA you cannot measure security. I mean, you could, but there's not a specific number that defines it. I don't know if
Okay.
it's clear.
Okay, good, thanks.
Later, I can, well, in this document is defined, so we can go through it if you are more interested in that. Okay, so yeah, I will continue. So yeah, in this RFC, it is defined that for handling and managing and controlling these IETF network slices, we need a controller, which is the network slice controller, which is the one that I am presenting today, that it acts between the customer high-level operation system, that could be an orchestrator, so that operates over the whole network, and between this component and between the network controllers operating the network, that in this case we are operating with a Teraflow SDN controller. Okay, so it acts at this point in the control layer. So then the ITF network slice controller, that I will call NSC for simplified, is defined by ITF, and it's basically a controller that orchestrates the request, realization, and lifecycle control of network slices. It consumes ITF network slice service requests coming from this orchestrator in the upper layers from the northbound interface. Then it maps this request to concrete technologies, establishing connectivity and allocating specific resources to slice, and then it implements them via its southbound interface to the southbound layers network controllers such as Teraflow SDN. And it exposes an API for creating, modificating and deleting these slices. So the architecture of this component, well, this is the current architecture of the NSC we have right now. I don't go through many details on it, but it basically has three main components. It has a mapper which exposes the MBI for receiving the slicing requests. These requests come in different formats. We will work here with the IDF slicing request that I will show you later, but it can also handle requests from 3GPP systems in other formats. Apart from that, there is also a realizer component that is the one that receive this request and translate it to the, let's say, to the Teraflow language for deploying the slice into a specific service. And we will be working in these tutorials and Hackfest with layer 3 VPN. So the request we receive for establishing a layer 3 VPN service. And it also has a slice database that stores all the information of the slices. So, well, I put this this slide for saying more or less what's new from this release. Well, for this release, a new web user interface was introduced that we will see today in this tutorial, and other things such as a containerization of the NSC for easing the deployment in cloud native and service-based environments. This will help in the deployment in the integration of the deployment with the TerraFlow controller. Also, enhance layer 2 and layer 3 slice deployment integrated with TerraFlow, and some other topics such as supporting energy-aware network slices, bug fixes, and many more things. So, is there any question up to this point? If not, we can go with the tutorial.
Yeah, I think Alain was raising a question in the
Ah,
chat.
sorry, I couldn't see.
Yeah, but probably you couldn't see. He was asking what is the protocol for SBI or of NSC?
Okay, well, in the definition of the, let me move here. Okay, in the definition of the NSC, there is no specification of the protocol used for the southbound interface, because it's technology specific. It depends on the controller you have below and the protocols that it accepts. In the case of TerraFlow SDN controller, probably Luis will know more about this, but as far as I'm concerned, it depends on if you use the TerraFlow SDN MBI or if you use the web UI. But for example, for deploying the layer 2 and layer 3 VPNs in the TerraFlow controller, we use the specific models defined by IDF for that are called layer 2 service model and layer 3 service model. I don't know if this solves the question, Alan.
Yeah, if needed, what I can do to complement, I will include in the chat the specific references, the RFCs, let's say, of the two data models that we are considering for the integration between the network slice controller and the controller, both of the TerraFlow. Just give me a minute and I will drop. Well, probably you can go ahead, Javier, and I
Okay.
will drop the message in the chat so that everybody has the link for later.
Okay, thank you, Luis.
I do have a
Okay,
question as well, if I can.
Okay, yeah, go on.
So where would be the how can I say that the intelligence of the controller, like all the past computation and everything, is it all done in the NSC, or you also have that into the TerraFlow SDN controller, or both of them, or like?
Yeah, it's some kind of mixed intelligence between the TerraFlow controller and NSC. I mean, the NSC is focused mainly on slice matters. So, for example, from coming request from the upper layers. In this component in the mapper, probably this request most of the times has not all the parameters that are needed for realizing the slice. For example, probably the customer here won't have full view of the real endpoints in the transport. Probably it will provide some others. So the mapper somehow has this intelligence to process and find the correct information to fulfill the request in order to be realized accordingly and to make the correct request for the controller, for the TerraFlow controller.
Okay.
Okay, so I will go then with the tutorial. First, for the tutorial, I I don't need that you follow me doing. I mean, I will just showcase how NSC is deployed and how can it be used. But well, you have available these slides to go for them whenever you need them, because I will show you later which are the challenges that require you to use the NSC, because some of them require it and some others are just needed with Teraflow SDN controller. So for the part of the NSC, first, it is important that you have Teraflow SDN deployed. This slide already was explained by Luis. You need to deploy with these commands the Teraflow SDN. And yeah, in case you are going to use also the NSC, you just need to check that it is already deployed, that in principle it is. So for the NSC, it's quite simple to deploy. You in your VMs, you will have a folder called TFS NSC, where you will have to enter and then just execute the command deploy sh to deploy the service. This will just build and create one container with the NSC image, and if you do Docker PS, you will see it deployed. So there are two options to use the NSC. It has an API that it is exposed in a Swagger panel like this. I don't know if you're familiar with these Swagger APIs, but I will show you in the tutorial. It's really simple to use. And yeah, there is this option, and there is the option of the NSC Web UI that, well, the links to enter both are like this. And it is true that the Web UI is somehow more, it has less functionalities available than the NSC API. So, but yeah, it's more intuitive to use maybe. So, well, you can choose between one each other, but take that into account. And also, yeah, the NSC code is available on this link in case you want to, well, you also will have it in your VM, but in case you want to check on this link, you have also the repo available. It's open source, so feel free to browse it and check whatever you want. Okay, and before, yeah, so before going into the demo, I would like to point out this file you will find in the well, in the NSC folder. If you go to src config mexample, this file will have some flags that will be important when you want to deploy the NSC. So I just pointed out some of the most useful flags. It's a description that you may find it useful, but probably most of them you don't have to touch them. But well, I will go through them later, but for example, here you can config the login level in case you want to see more, you want to debug more on the logs. You have, for example, this option that is the dummy mode that if you set it to be activated, you can play with the NSC without like putting the request into Teraflow. So in case you are just developing, debugging, and you want to test without Teraflow, you can put this dummy mode into true to avoid sending the information to to Teraflow. And yeah, there's also this flag to deploy the Web UI. And yeah, so for the NSC, well, in case you do the challenges 5, 6, 10, or 11, you may need to deploy it. So in case that your team arrives to these challenges, just keep in mind this demo I'm going to show you now. So let me open now. Well, I have some notes here. Okay. So first of all, well, here I have my okay. I will check here that I have TerraFlow running. You can check it with this command. This is kubectl get pods, and you see all the pods running for the TFS. And in other window, we have the NSC. So here I have opened the emp example file. As I mentioned here, I have changed some things because, for example, this you will have it to the local host, probably because in my case I have the TerraFlow. I'm playing in a local environment, so I have the TFS deployed in another server, but the rest probably you will have it like this. So anytime you want to deploy, you should check these flags to know which configuration you have. And also, I want to show you this file. Probably you won't understand many of these, but basically this is the file that the NSC will send to the NSC. And in here, you can see some of the requirements we are putting here. For example, we are defining this slide with this bandwidth. Also, we are defining a latency of 5.5 milliseconds and some other things like the availability that it's at 95%. There are also here, referring to the question made before of the SLEs. In this case, there are no SLEs defined, but you can define here security, isolation, path constraints, and some other things. So yeah, so as I mentioned, this is the request we will send. I don't know if Luis provided this, but if not, we can upload it later for people to use it in case they want to play with the NSC. So let me open now this another window. Here we are going to deploy the NSC. Okay. So this won't take so much time because I already deployed it before, so maybe no more than 20 seconds will be needed. Maybe if it's your first time, it will take some more time, but I don't think so. So let's wait until it is deployed, and we can access the different services. Okay. Well, meanwhile, I will access here. This is the TerraFlow SDN web UI. So you will access it through your API, IP, and within web UI. And here you will have already your topology deployed. I think that mine now is different from yours, but well, don't worry, it is very similar. And here we can check that, for example, there are no services deployed, and we just have these 5 devices deployed. So I will come back to the, well, it's taking more than expected. So I will let's wait until it finishes. But what we will do is basically deploying and slice, and we will do it through the API and through the web UI. I don't know why it's taking so much. Okay, never mind. I will see because as I deployed before, maybe we can still. Oh, it finished. Nice. Okay. Okay, so now it's ready. Okay, so to check, you can do Docker PS. And in Docker PS, you see here that the NSC service is deployed in the 8085 port. So now, if we go back to here, if you access your IP 8085/NSC, you will have the Swagger panel. In this Swagger panel, you will have a lot of namespaces, but the interesting one is this one called TFS, that are the operations related with transport network slices with Teraflow LDN controller. So here you have the common CRUD operations. You have create, read, update, and delete. And for example, what we are going to do is deploying and slice with the file I showed before. So if I enter here, I have it here. We have the L3 VPN test. And if we execute it, you see here, it went really fast. It says, I will put it here. It says success true, and it says that it has deployed these slices, what is just one, with this ID, with this source and destination, with the VLAN 100 and the requirements we talked about. This bandwidth, this latency, availability, and the MTU. So I think that okay, I deployed with the dummy mode put to true. We will later put it to false to check that here it is also created. But we can also access the web UI. Okay, so in the web UI, you will be interested in this one. Here, you have direct access. If you click here in the web UI, you have access to the Teraflow web UI we saw before. And if you click here, you can also create your own slice as if you were a customer. So for example, I will put this slice between 1.1.1 to destination 2, VLAN 300, for example. I will put 5 milliseconds of latency and 100 megabits. So as you see here, we cannot put for the moment more than latency and bandwidth. So as I mentioned, it is more limited. But if we do generate the intent, we see that here these are the characteristics generated. And if we go to search, we see the previous slice created and the current created slice now. So I'm going to change now in the layer 3 in the flags. I'm going to put the dummy mode to false to see that slices are now sent to Teraflow. So, I will first remove them. So it's very simple. You go to here, delete, you go to try out, and if you execute, when it says code 204, it is good. it means that all transport networks have been deleted successfully. In fact, if you can see here that if you execute, you have a not found because there are no slices found. So if I repeat what I did before, just to show you, I will execute it. Okay, success true here. If we do the get and retrieve all the slices available, you see here all the slice in the format we saw before with the different characteristics. And here at the end, you see that the controller handling the slices TFS is the TerraFlow SDN. So again, I'm going to delete it. Now it's deleted. And I'm going to redeploy that. I hope this time it takes less time. So let me clear the screen. And again, I'm going to deploy. So it just stops the current container, deletes all that there could be. And you see, this time it took less time. Nice. So now we check again that it is deployed. It is deployed here. Nice. And if we go back here, now I expect that when we send a slice to the network controller, a new service will be created here. That it should be a layer 3 service. So we go to post. We again send the layer 3 VPN test slice. We have a success. And if we go to TerraFlow, okay, we have the service now here created. So if we enter here, clicking, I will also put this bigger. You see here that we have created a slice, well, layer 3. Well, the layer 3, I don't know where it's mentioned. I think it was here. Okay, we have the type layer 3, a layer 3 service created, and it is between these two endpoints in topology. It has these constraints, these 4 constraints, and it has here more details on the service, and you can see here the path for the slice that is between 1, but it goes through 4 until device 3. That it is basically this path, I guess. Well, this is 5, this is 4, 1 and 3. Yeah, so it goes like this, between these 3 nodes, the service. Okay, so I don't think I have much more time. So I think it was an introductory tutorial for the NSC. As I mentioned, you can play with the different values here. As I mentioned here, you have the login level, you can change. These dump templates, for example, if you set it to true, you can see how the request is translated, and you can see what it is really sent to TerraFlow. As I mentioned, the dummy mode, you can put it in true or false, depending on whatever you want. The web UI, if you want it activated or not. So yeah, you can play with this. And yeah, that was, I think, all I wanted to say. So thank you very much. And I don't know if there are any questions before wrapping up.
Yeah, thank you. Just one question. So you show you have your own the web UI. Can we use simply with the external tool like Postman to do the similar things?
Yeah, sure. You can use it through Postman. I mean, in the API, you may see the like the URIs of the request. So yeah, you can use it however you want this. the solar panel is just for facilitating and illustrating more easily how to use the API.
Okay, great. Thanks.
You're welcome.
So thank you very much, Javier, for this nice tutorial. More questions for Javier, even when we had a number of questions during the presentation. Is there any other question you want to raise? Seems not. Well, I think we can close the tutorial here, and for sure, if some additional question arises later, we can raise it and resolve it maybe in the open Q&A sessions or through the Slack channels. So thank you very much again, Javier, and